Good day. I am Opa, and in this study, I will be addressing hard drive reliability. Have you ever lost data due to hard drive failure? This work brings the science of data to bear on this kind of misfortune. As computer use has become ubiquitous, the use of hard drives to store data has been growing exponentially. Drive hard failures can indeed be costly and painful, especially as more voluminous and frequently valuable data is stored on them. The causes of hard drive failures are varied. Some may be due to unforeseen mishaps, while some may be more preventable. As you can see, not all causes are easily preventable. Nevertheless, this study will examine the details for those failure causes which are. Some years ago, a Google paper reported that up to 40% of units being studied, which failed, did not have any associated smart flags. Smart. One might be asking, what is that? According to Wikipedia, SMART, often written as SMART, is a monitoring system included in computer hard disk drives to detect and report various indicators of drive reliability so that software running on the host system may alert the user. Thus, the failing drive could be replaced with the ultimate goal of data integrity being maintained. The data source. Every month since 2013, Backblaze.com has been posting a spreadsheet which stores more than 50 of the 255 smart hard drive monitoring metrics published by hard drive manufacturers. After extensive review of the data, I selected the data subset from Seagate units having model number STD4000DM000 and also meeting the condition that they failed in 2019. This is because that model's units seemed to have a fairly consistent performance profile. In order to determine how to predict lifespans with smart health monitoring attributes, at first a regression analysis was performed using the remaining useful days as a target and monitored attributes as features. The accuracy of this model was low. I then tried a different approach. This time, the observed lifespans for the units were grouped into 12 sets. These group labels were fed into an ensemble of tree classification estimators as targets, again with monitored features as inputs. A tree classification algorithm seeks to branch through decisions as a means of categorizing its outputs. An ensemble was chosen in order to increase accuracy. Note that the extratrees ensemble randomly chooses the thresholds for determining Guinea impurity. On the other hand, random forests, another ensemble of decision tree classifiers, uses a fixed level for the Guinea impurity threshold. Both algorithms expose random subsets of the data to each of the subestimators. Using the extratrees algorithm, the average accuracy 0.8 81 was much higher. Furthermore, the top feature, when weighted by importance, was the load cycle count. Observing the accuracy rate, we can say that for each unit, the algorithm predicts, with a greater than 60% success rate, whether it will suffer very early death or operate closer to the typical lifespan of greater than 40,000 hours. In closing, thank you for listening to this analysis. You can reach me for follow up by directing an email to workhead@hotmail.com.